Good afternoon, my chemistry minions. Mr. Milks here with another installment of lecture videos for Unit 1. Today, I am guessing if you're watching this video, you are on page 18 and 19, and we are about to explore matter and the way we separate and classify it. We are going to start into the nuts and bolts of chemistry, the heart of the matter. So on paper, chemistry definition is the science that studies matter and energy and how they interact with each other. Now, we did matter already, of course. Matter is anything that has mass and takes up space, i.e. has atoms. Okay, everything is made up of atoms, even though we can't see it. You get enough of them together, you can get a big chunk of atoms, and there's some stuff I can see. Now, Mr. Monaco and I went back and forth on this. This is the best we could come up with for us. So in our chemistry class, we are going to think of energy as heat, light, and motion. Those three words are going to sum up everything we need to know about energy for this class until we start to quantify and change units with energy. Heat, light, and motion. Now, the classification of matter and understanding these particle diagrams. Particle diagrams are going to be big for us, and they are probably going to be on our tests. So I'm going to do a lot of talking here. You are going to do a lot of writing and listening and understanding, even though I don't have any prompts for you to write, but I need you to understand what I'm about to say. As a matter of fact, in a second, I'm going to ask you to pause this screen, and I'm going to ask you right now. Mine is beautiful and colored. Yours is not so much. So I would like you to, with whatever means necessary you have, try to decipher your atoms from one another based on the color I have. Especially if you look over on the far right over here, and I see these molecules of water, and you see how there's green and red? And on your paper, it doesn't show up so good. So let's make sure the different colored atoms have different colors in some way. You do it however you can do it. You can hit pause now and do it. Ready? Hit pause. Go. All right, now you unpaused, right? Because now we're back. Now I'm going to talk. All right, so elements up top left-hand box, elements. I'm going to circle my box. Notice in this box, I have single spheres called atoms. Okay, notice they are all green. We are uniform. So this is homogeneous, all the same. And because there's only one atom each, we're going to call that diatomic. Whoa, I misspoke, Mr. Milks. You just had way too much coffee. I'm sorry. Let's fix that. Monatomic, one. Mono is one, atomic, monatomic. Monoatomic. Atomic. Mr. Milks, can you learn how to spell for crying out loud? All right. The reason I wrote that is because now we're going to differentiate. Another way to do atoms is to have two of the same atom linked together. But notice this particular sample is uniform throughout. It's all two spheres of the same kind. That is a molecule of an element, but now it's diatomic. Here, that you can see better than that monoatomic. This is called diatomic. Two atoms of the same kind that come together to form a molecule, but notice that each one of the molecules is exactly the same. So I have a pure substance that is an element. Okay? Okay, deep breath. Now I'm going to move down here to the bottom real quick to do compounds. Because compounds have something very similar and something very different about them in relation to elements. First, let's do similar. Notice that each molecule here in the compound is exactly the same. That makes it a pure substance, just like in the element with the green dots. But each molecule is made up of different atoms. That's what makes it a compound. So both elements and compounds in this case are these pure substances because they're the same all the way throughout. Now we'll get into the middle. Sample of a mixture. Well, first sample would be to take two lone elements, two monatomic elements, and put them together in the same canister. Okay, so I have orange and I have green in this particular example. You can have, green and red or blue and yellow, whatever you got handy. But make sure you have different colors in there because now that's why it's a mixture. It's not the same throughout. It's what we call heterogeneous, different. Okay, another example of a mixture is the second box. I have monoatomic atoms and I have diatomic elements and monoatomic elements. Two different kind of elements. That's the key. Okay, two different kinds of elements. I got blue ones and I got green ones. That makes it heterogeneous. It's not the same all the way throughout. Now, this next one's just another little bit of a variation. I know it's kind of nitpicky, but here I have two diatomic elements. But the key is that there's one element is this pink stuff, and the other element is this purple stuff. Two different kind of diatomic elements. Put them together, I have a mixture. I'm not the same all the way throughout. And then, of course, we have one last, now that we have elements and compounds defined, this last example is a diatomic element, that would be this, combined with a molecule or a compound. This compound is not the same. So now I am not the same all the way throughout. I am heterogeneous, and I have different stuff. And I can see it very clearly. So here is our first example of what we call particle diagrams that help us understand what is inside what we're looking at. Okay? Thanks, Mr. Milks, for the next slide. And look at all this writing all over this. Let's see if we can get rid of this before we get going, because we got to get through this. This is going to be a long video. Come on, go away. Go away. Mr. Milks is having technical difficulties. Please bear with us. There we go. All right, sorry this is taking so long. I'm going to speed it right up. Now let's take all this information that we have and let's bring it together in a written form. So here's what you get to write. Ready? Matter is, of course, anything that takes up mass, takes up volume. Okay, I'm sorry, I'm going to start talking fast because I want to get through this for you because it's getting so long. To the left, cannot be separated by physical means. So pure substances, it's the same all the way throughout. I can't separate one molecule or one atom from another because they're the same thing. I can physically separate them, but it's just, I'm not going to get one away from the other. It's the same kind of thing. So I'm not really separating them, if you see what I'm saying. And I can physically separate them. So it's two different classes. If I can physically separate them, that's mixtures. So think of like sand and water. Real easy to separate the sand from the water. But if I had just sand, I can't separate sand from sand. You see what I'm saying? That would be the pure substance. Or water. I can't separate water from water. All right. So if I'm going to go down under pure substances, it says I cannot be separated by chemical means. Well, that is the definition of an element. The simplest form of matter, we went over monoatomic and diatomic as far as what the way the elements are represented. If I was to draw a particle diagram, I would draw something like this. This is a diatomic element. I cannot separate it by chemical means. There's nothing chemical I can do to it. Okay? But there are a class of pure substances that can be separated by chemical means, and that's compounds and molecules. Because there's different atoms in there, I can actually chemically break some of them apart. And now here's a particle diagram. This particle diagram is of water. The water is made up of hydrogen and oxygen, so there's two different elements in it. It's not an element, it's now a compound or a molecule. And because of that, I can separate those two elements from the molecule using a chemical means we'll learn later on. It's called hydrolysis. Now to finish the right-hand side, things that can be physically separated are mixtures. A composition that's same through all the way throughout is homogeneous. Homo means same, uniform all the way throughout. A particle diagram would be something like this, two diatomic elements. Think of salt water or iced tea, or in your, Kool-Aid. You know you took sugar and you put it in the water, in the colored Kool-Aid. You stirred it all up, but now it looks the same all the way throughout. You can't tell that there's two different things. That's homogeneous. You see one thing all the way throughout, but you know it's a mixture. You put the stuff together. We will get deeper and deeper into this later on and discuss different names for different things. But as far as today goes, this will suffice. Okay? The other option we have is heterogeneous mixtures, not the same throughout. Think of Italian dressing or chocolate chip cookies. Here's a particle diagram of a bunch of different things together. I can actually see that there's different stuff. If I look in a chocolate chip cookie, I see the chocolate chips. That stuff is very visible. It's very obvious that it's a mixture of two different things, and I could separate them. Okay? I could run the Italian dressing through a strainer and get all the stuff out of the oil. Okay? So that is going to just about wrap us up today. If you're having any trouble with compounds, mixtures, and pure substances, by all means do a keyword search. This is also very visual, so go ahead and do an image search, and you might find some better pictures than I have here and increase your understanding, and that's, of course, what we're looking for. Sorry this went on so long, guys, but it's late. I'm not going to re-record it. See you tomorrow in school.